going to study Fourier series analysis. This series is an important topic in electrical and electronic engineering. Another important thing, not in electrical and electronics engineering Fourier series use, it uses another engineering sector also, mechanical and civil, especially civil, when they design a bridge, then they use this Fourier series. And in mechanical, that when the heat transfer analysis, they use this Fourier series. Okay, but in our case, Fourier series in signal analysis. We have signals, right? Like sine wave, cos wave, triangular wave, sawtooth wave, various types of signals. So we use this Fourier series to analyze a signal, its fundamental components, various types of harmonics, understand? So this Fourier series is kind of important in our field. Everybody needs to study well this topic. If we look this definition of Fourier series in terms of engineering, so you can see the Fourier series is a composition of sine and cosine functions. So everybody is familiar with the sine and cosine functions, right? Speciality of Fourier series is they define the signal in terms of sine. So from that sine and cosine function, we can write down the series in terms of x of t equals to a0, a1 cos omega t plus a2 omega t plus a3 cos 3 omega t plus so on, an cos n omega t. And in terms of sine, b1 sine omega t, b2 sine 2 omega t, b3 sine omega t, and so on up to bn sine n omega t. So this is the series. At this series, a0, an, b1 to bn, they are called coefficient of Fourier series. A coefficient of cosine term, B is the coefficient of sine terms. Make a form of Fourier series, then it becomes A0 plus summation of n equals to 1 to alpha in infinity actually here. So an cos n omega t plus bn sine n omega t. This is the Fourier series.
Yeah.
Very interesting point is here, the coefficient is absent.
Yes, sir.
B0 coefficient is absent because when sine omega value is 0, because here is n values are the number of based on frequency. When frequency is 0, then the sine terms is 0. That's why B0 not existed in the series. Is it clear?
Yes, sir. But here, sir, A0 equal cos 0 degree equal 1. That's why A0.
Yes, thank you. Thank you, Shojal. Yes, this is the right answer. So here we can define is in terms of electrical engineering, that is DC component. DC signal has no frequency. So we can consider it is DC component. Then we have fundamental AC component. Fundamental AC component means the frequency, the fundamental frequency means the single frequency. There is no other frequency. Second order harmonics, that means double frequency signal. Double frequency signal is called second order harmonics. Triple frequency component is called third order harmonics. By this way, we can say nth order harmonics means an cos n omega t. Similarly, Bn sin omega t harmonics. You can define a signal in terms of sine and cosine by the definition of fundamental, second order, third order, and nth order harmonics. The objective of the series is to find out the, because we don't want noise, right? Another.
Yes, sir.
You can very interesting point. Component. We always want the original signal, that is desired signal, and desired signal all the beyond this fundamental component, we have always harmonics that usually or generally it is called noise. So noise will be always with the, okay. So we need to ignore the or the subtract the noise from the original function. So how can we ignore that harmonics? Then we have to make a filter, right? Filter circuit.
Sir.
Now visible?
Yes, sir.
So if we look at this harmonics level, so you can define which harmonics you want with the fundamental. Of course, usually we don't want harmonics, but it is in reality, all harmonics will be with the fundamental components. But we have to minimize the harmonics level. We have to minimize the harmonic level, otherwise we cannot get the original signal. That's why the signal will be distorted. If we have multiple harmonics, then the signal will be distorted, not smooth. To make a smooth signal, then we have to use a filter. So the objective of Fourier series in electrical engineering, one of the objective is to design a filter, use Fourier series. Another objective, analysis a circuit in frequency domain. Frequency domain. Okay. So second objective of study Fourier series is to analyze a circuit in frequency domain. Okay. Everybody clear the objective of studying Fourier series? Now everybody see the Fourier series. Now we are moving to find what are the coefficient of Fourier series. Here
Yes, sir.
the coefficient formula of Fourier series, A0, AN, and BN. So a signal used to have the 360 degree, right? One cycle is 360 degree. That is twice pi. Find out the A0 in terms of angle domain, we can say angle scale. Then we write down 1 over twice pi, 0 to twice pi x of theta d theta. 0 to twice pi x of theta d theta. Okay. In this case, the signal should be positioned from 0 to 0. It starts from 0. Okay. So here the interesting thing is that I'm going to draw one more things here. Look at axis. I am making the x-axis and y-axis. So
Yes, sir.
look at this point one. This is the x. I just insert. Text is, that is theta. If you consider theta, insert symbol. That is theta. Okay.
Yes, sir.
So up to this point is pi, right? Because this is going to be the half cycle.
Yes, sir.
There is 0. There's going to be a pi signal pi. Look at where is pi. Okay, I'm writing in terms of pi. Okay, pi pi. All right. So the amplitude is this one, and it starts from 0. In this case, the formula going to be 0 to twice pi x of theta. X of theta means this signal. X of theta is the function of the signal. In case of sine wave, the function of signal will be the Vm sine theta, right? Sine wave function is Vm, the maximum amplitude multiplication with the sine theta.
Yes, sir.
Okay. So the function will be changed according to the signal types. Such as if you have the sawtooth wave, the function will be the different. If you have the what is called the triangular waves, then you have the different function. So function depends on the signal types. All right, x of theta. So if the signal starts from minus pi to pi, still it is a twice pi. The limit is same limit, minus pi to pi, and 0 to twice pi, limit is same, twice pi. Okay. So the signal formula is going to be the same. The 1 over twice pi minus pi to pi x of theta d theta. This is based on the angle scale. If we change to time scale, formula is changed to 1 over t, 0 to t, x of t dt equals to 1 over t. That is another term, formula. If the signal is delayed, the t1 time is delayed, then the formula is going to be like this. But the overall, the scale, time scale are the similar form, because t is the one cycle period and one cycle is twice pi, right? One cycle is twice. So the formula, both formulas same, just the scale is different. So in this case, the 0 and the this theta are going to be t, okay, and here will be what, t by 2, half cycle t by 2, okay, full cycle going to be another one. So if we make this, okay, just to make you understand. Sine wave is going like this way, right? So it's gonna be touch the part. Take it the other way. Although it's not the perfect one, but similar, you can think this going to be connected here. All right. Okay. So here going to a T. So this is one cycle. So the A0 becomes 1 over T and 0 to T x of T dt. This is going to be the formula of A0. In case of AN, the similar way, the angle base 1 over pi, 0 to twice pi x of theta cos n theta d theta. In terms of time scale, 2 by t, 0 to t x of t cos n omega t dt. So if A0, what is the different AN? A0 was 1 over twice pi, 0 to twice pi, x of theta d theta. Here is 1 over pi is going to the half. 0
Yes,
to
sir.
twice pi x of theta cos n theta d theta. Why here is AN is half? The reason behind it, if we took the take the AN for full cycle, so such as this cycle.
Sir, first line, sir. Can you hear me, sir?
First line A0.
Sir, how the integration limit is, sir? Minus pi to pi, sir. To 2 pi.
2 pi.
Yes,
Okay,
sir.
okay. Minus pi to pi. Then signal going to be start from the left side. There will be minus pi. Because the zero origin is here. Here is the 0. Okay. So signal starts earlier than origin. So in this case, minus pi starts. Minus pi to pi.
It is
Okay, sir. Thank you, sir.
one
Okay.
cycle, sir.
Yes, one
Completed
cycle.
one
We have
cycle.
to consider one cycle. Always. This way. So remember, here is in the video, you can see maybe it is different. Here will be the pi. Okay. Up to 10. Here will be 0. Here will be 0. And there will be theta. Okay. So remember, this is not t, this is theta. So it's clear the first coefficient A0. Second coefficient is AN. And that AN always will be half cycle calculation. Half cycle calculation for the averaging, not for the limit. Remember, not for the limit, it's averaging. Because that what I want to say, if you consider the sine wave, they are the positive half cycle and negative half cycle, both are symmetric, isn't it? So in case of symmetric, if you make a average, there's gonna be the 0. Because here is positive, here is negative. Above the reference line positive, below the reference line is negative, but they are the identical. So in identical, the positive and negative becomes 0. That's why for averaging, AN becomes half cycle calculation. Okay, 1 over pi. But limit is same, 0 to twice pi. Understand?
Yes, sir.
So in case of time base, what was the A0? 1 over t. But in this case, 1 over t divided by 2. Isn't it? 1 over t divided by 2. That means 1 over half t. So that 2 going to be in upper of the t. That's why 2 by t. So 0 to t, x of t was n omega t dt. For Bn, similar. For Bn, similar, just we need to change in sign terms. Like 1 over pi, 0 to twice pi, x of theta, sine n theta d theta equals to 2 over t, 0 to t x of t, sine n omega t dt. These 3 coefficients you need to find out for Fourier series. After that, you will make a series, because if you see the previous slide, here you can see the series already ready. If you have AN, BN, and A0, you can make the series automatically. Because in that case, the frequency number will be the only change. Frequency number going to change. Just you need to put the coefficients only. Understand? So the finding coefficient is a important work in Fourier series. If you do mistake here, then you cannot have the result correctly. Up to this, anyone has any question? They are all.
Sir,
Do you have any question?
Yes, sir.
if x
Yes.
equal summation of C and E.
Oh, this is another. Just I am asking up to Fourier coefficient.
Yes, sir. I want to ask a question, sir.
Yes, Jim, please ask. What is the question?
In this slide, n S0 is equal to 1 by 2 pi, then integration 0 to 2 pi. Yes, sir. Then the second line, 1 by t, integration 0 to t, sir.
Yes.
What does that mean, sir, actually? 1 by t is 2 pi. T is equal to 2 pi, and 0 to t is equal to, sir, 0 to 2 pi, sir.
Yes, T equals to twice pi. Look
Okay,
at
sir.
this
Okay, sir.
diagram.
Then-
One period is what? One period. One cycle period
half
is
T, sir.
T.
Yes, sir.
And it in case of angle, what is the one cycle? 360 degree, and 360 degree means 2
2
pi.
pi. Okay, sir. Yes. Okay, sir.
Is it clear?
Thank you. Yes, sir. Yes.
Any more question?
No, sir.
Okay. So here I want to give you another clarification. If your cycle is up to pi, that means 0 to pi, then an will be what? Half of that cycle, isn't it? In this here.
Yes,
here,
sir.
here is in case of full cycle 1 over pi. Then if the limit is half cycle, then that coefficient, the front coefficient will be again half, right? So
Yes, sir.
2 by pi. Everybody clear?
Yes, sir. Yes, sir. Yes, sir.
So remember this limit. To solve the Fourier series, you need to find out the coefficient correctly and select the function correctly, select the limit correctly. If you do these three things correctly, you will not have a wrong answer. You will have the correct answer. So next formula is x of theta summation of n minus infinity to infinity Cn e to the power j n omega t, where Cn equals to 1 over t 0 to t x of t e to the power minus j n omega t dt. This formula is called the exponential form of Fourier series. So they have the same answer actually. Previous one, this one called trigonometric form of Fourier series, and this slide one is called exponential form of Fourier series. So actually e to the power j n omega t equals to cos n omega t plus j sin n omega t. Understand? That's why the exponential form, if we make the exponential form, it is much easier than trigonometric, but solving Fourier series, the trigonometric form is easier. Understand? Because in that case, individually, it takes time, but it can give you the satisfaction. But in exponential form, taking less time, but it makes confusion. That's in two form. But at the end of the solution is the same for both formulas. Okay. So today, up to this, if anyone has